Hello. Hello and welcome to this video on weakref module of Python. So this is the second video. We will finish the read through and then we will see an example. The example is quite simple, which will demonstrate the conceptual uses of weakref. So we first finished the read through. There is not much here, but it will show that what weakref can be used for. And if you have not watched the previous video, then it is recommended that you watch it, otherwise you won't understand it. So this example says that this simple example shows how an application can use object IDs to retrieve objects that it has seen before. The IDs of the objects can then be used in other data structures without forcing the object to remain alive, but the objects can still be retrieved by ID if they do. So here it creates a weak value dictionary, weakref.weakValue dictionary, and there are two functions. Remember, so it takes an object and computes the ID of that object, and then against that ID it assigns the object and returns the object ID. Then ID to object is you give the ID and you get the object by using the get item function call. So see, this returns the ID and here you get the ID using object. Then we have an example of finalizer objects. The main benefit of using finalize is that it makes it simple to register callback without needing to preserve the return finalizer object. For instance, so we have a empty class object and we create an example object of it, and then we finalize that using weakref. So Kenny print and you killed Kenny. Okay. So if you don't remember finalize, you look at here, you have object, function, and arguments and all that. It returns a callable finalizer object, which will be called when object is garbage collected. So this function print will take this argument and print it. Okay, when Kenny will be finalized. So we register that, and when you delete Kenny, it will be garbage collected, and this callback will be registered and it will print you killed Kenny. The finalizer can be called directly as well. However, the finalizer will invoke the callback at most once. So we have a callback on XYZ. It prints callback and returns X plus Y plus Z. You create an object and finalize it. Okay. So callback is this function, and 1 to Z is equal to 3 are 3 arguments. Now at this moment it will be alive. Then you call the finalizer by calling F and you get 6 as the sum, and then this F won't be alive anymore. So if you call it here, then you want the callback cannot be called, it won't do anything, and then you delete the object. You can unregister finalizing using its detach method. This kills the finalizer and returns the arguments passed to the constructor when it was created. So we create the finalizer and then we detach it, and once you detach it, you get new obj func args kw args, and that is whatever is returned is ignored actually. So you assert here f dot alive. Okay, so it is no longer alive, and new object is object, this which you get here is equal to object, and function args and kw args when you supply to the func, which is the callback of this example here, will be 6. Unless you set the exit attribute to false, the finalizer will be called when the program exits if it is still alive. So here when we exit the program, the finalizer of print will be called. It will print object dead or exiting. Comparing finalizers with the delete methods. Suppose we want to create a class whose instances represent temporary directories. The directory should be deleted with their contents when the first of the following events occurs. The object is garbage collected, the object's remove method is called, or the program exits. We might try to implement the class using the del method as follows. So we have temp directory, and you create the temporary directory in the constructor, and remove function. If the name is not none, you call shell utilities and call rm tree on that and set name is equal to none. And the removed property returns none, returns true if self name is none. And finally we delete, we call self.remove here. Starting with Python 3.4, del method no longer prevents reference cycles from being garbage collected, and module globals are no longer forced to none during interpreter shutdown. So this code should work without any issues on CPython. However, handling of del method is notoriously implementation specific, since it depends on internal details of the interpreter's garbage collector implementation. A more robust alternative can be to define a finalizer which only references the specific functions and objects that it needs rather than having access to the full state of the object. So you create the directory here, and in the finalizer attribute you put a finalizer where your callback is sh-util-rm-tree and self.name is argument, and you call the finalizer here. So this rm-tree won't be called again. So what can happen here is, say for example, you delete this object, okay, and you can invoke delete again. So that's not a good thing. It will cause an error, but finalizer can be called only once. Defined like this, our finalizer only receives a reference to the details it needs to clean up the directory appropriately. If the object never gets garbage collected, the finalizer will still be created at exit. The other advantage of weakref based finalizers is that they can be used to register finalizers for classes where the definition is controlled by a third party, such as running code where now module is unloaded. So here you have weakref and sys. In the finalizer, you call the module's name. That is, you invoke the module and you call unloading module here. Okay, so that's it. There is not much to the weakref module. Now we will look at the example which I have created. So, okay, let me increase the font. Let's get rid of this AI. I don't use it anyway. So here we import the module weakref, and then we have the GC module. So GC module we have not covered yet, but very soon we will cover it. So I have created a class which has a constructor, takes two arguments, document ID and title. The self is also already there, always there. That's why I have not counted it. And we create two instance variables, document ID and self.title. Then the rep call will refer to the document ID and title, and delete will make sure the object is destroyed. Okay. And now we create a document cache, weakref.weakvalue dictionary. So as you can read in the documentation, so where was a primary use for weak references is to implement caches or mapping holding large objects. So that's what I have tried to create. So we have a load document function which takes a document ID and title, and it first tries to get the document ID from the document cache. So if the document is found, it returns the document. Now if the document is not found in the cache, we create a document object. Now I can assume that this document is expensive to create. It might be a big file. So we create this, and against the document ID, we store it in the document cache. Now we load the document 101. So it will be created and put into the cache. So at this moment, document cache will contain the ID 101. And we load the same document, then it will get the document from here and return us the document. So document 2 will be loaded from the cache, and you will see that doc1 is same as doc2. Okay, now we delete doc1 and doc2 and we invoke the garbage collection, and you will see that document cache is empty here, And if you try to load the document again, this will return none, but it will return the doc3 as well, and document 3 will be contained here. So let's see this in example. So we run this as Python weakref example. So as you see, we have all that. This extra line comes because at the end the code will exit and doc3 will be garbage collected. So this line is coming from there. Okay. So as expected, first we try to load the document from database. Okay. So when we try that, it won't be found in cache and it will be put inside the cache. Okay. It will print loading document from database. Okay. As you can see, it says loading document from database and then cache is printed. And on the second one, we load the same document and doc2 will be found here. So returning document from cache will come. And doc1 is doc2, which is true, and we delete our references and it prints document 101 destroyed and cache becomes empty. So that's the example which is there, which you can create using weakref. Now as you saw, finalizers can be quite useful here. For example, in this one, we saw that the finalizer is quite important, not this one, this directory removal example. So that the delete call does not call the finalize twice. Finalizers are called only once as the name specifies. So with this, I will end this video here and let's see what awaits us in the next one. So next is types. Very interesting. So again, this will take probably 2 videos to go through all the documentation. And okay, coroutines are there. Okay, we will have to go through coroutines. All right. So in the next video, we will continue with the typing module, types module, rather, not typing module. And we will learn something. So I hope that this video was useful for you and you learned something about Python weakref. So thanks a lot for watching the video. Have a great day. Stay curious, keep learning. I'll see you in the next one with the types module. Till then, I will take my leave and you enjoy.